So this is quite an involved complex transformations problems for Edexcel. A couple of ways of going about this. I'm going to rearrange and adopt that kind of approach, and I might in a later video do the same question with a different approach. So let's just do it by the rearranging method. So we can say W is equal to Z plus I, we're doing part A, over Z. WZ is equal to Z plus I, and WZ minus Z is equal to I. So Z is equal to I over W minus 1. Okay, so now I'm going to sub in, what I'm going to do is sub in U plus IV and then compare our original locus to the final locus and see what we can do. So let's sub in U plus IV because that's what we've got. Our Z numbers, Z is X plus IY, and our W plane is our U plus IV. So let's sub in U plus IV minus 1. It's going to be a lot of work here for the 5 marks, but I think if I adopt this approach it will help with part B as well, because this rearranging I'm going to use this form for part B too, so hopefully it will pay off. So we've got Z is equal to I over U minus 1 plus IV. I'm now going to rationalise this by times it by the complex conjugate. So that's U times U minus 1 minus IV on top and bottom. Okay. Right. Okay, so let's just work with that. Okay, so we've got, even itself there, well, is it? Okay, let's do that. Okay, so now let's multiply it out. On the top we get U minus 1 I, and because it's minus I, that's going to be plus V, because it's minus I squared, which is 1. And on the bottom we've got the conjugates. We've got U minus 1 squared plus V squared. Okay, now let's get this into a real and imaginary form. That's U minus 1. Oh, no, let's get the real part first. V over U minus 1 squared plus V squared plus U minus 1 over U minus 1 squared plus V squared I. Okay, so we haven't really got going particularly yet, but we notice that the left hand side is X plus IY, and they're saying that the equation is Y equals to X. So basically we're going to make these two equal to each other. These two here equal to each other. That one and that one. Because Y equals to X. So we have V over U minus 1 squared plus V squared plus is equal to U minus 1 over the same denominator. And lo and behold, of course, the denominator cancels. So we'll get V is equal to U minus 1. It has said, I don't know how, I haven't looked at the scheme. I think they do it a different way anyway, but it has said here other than 0, 0. I don't think for FP2 we really need to bother with that, but I would do just in case. And for those of you who are doing step, this might, such a thing will take up on step 3, you can bet that they would definitely want you to say that 0, 0 is undefined. Yeah, because you've got w is equal to z is equal to 0 is undefined because of this. Because we've got the z as a denominator here. So we would definitely need to division by 0 is not possible. But I don't think, well, we'll have to look at, I haven't looked at the scheme, but I suspect that I'm not going to be too concerned with that in FP2. More for step people, really. Okay, so part B, well, there is a slightly easier way of doing a y equals x perhaps for part A, which I'll do in another version. But one of the advantages of taking this rearranging approach is that actually we're going to use exactly the same thing for a different loci here. So if we have x plus y plus 1 equals to 0, we've done a lot of the hard groundwork here, legwork, in this rearrangement, not that part, but up to here. All the legwork up to here has been done. We've got z in terms of v and u, and we can now sub that into here. So it's one of these things where you are working harder for the 5 marks, but we're getting a bit of a benefit for the 7 marks. I don't think the examiners had anticipated us doing this way, but I do think it is the most efficient way. So x is this bit here, so that's v over u minus 1 squared plus v squared, plus u minus 1 over u minus 1 squared plus v squared, plus 1 equals 0. So let's just get on with it and multiply it out. V plus u minus 1 plus u minus 1 squared plus v squared equals to 0. Just multiplying out by the denominator. So we have v plus u minus 1 plus u squared minus 2u plus 1 plus v squared equals to 0. Are we going to get what we're asked to show here? U squared plus v squared, and then we've got a plus u, no, we've got a minus u, and we've got a plus v, and if other things cancelled as required. As I say, 7 marks for that, but as I say, I think some of those 7 marks were actually really, the person who wrote the question and who put the question in the scheme has obviously done it a different way, which has given a different mark allocation. Anyway, on the same Argand diagram, sketch L and C. L was our line, and C, where C, so the image of T, and this, and that's a circle. So this is almost like a bonus, really. Feels a bit like University Challenge, where the hard question's the first one, and then if you get it, you get a few bonus questions after that. Okay, so we've got the line V is equal to U minus 1. So we've got V, U minus 1, that's going to be that line there. Does it want to on the same diagram? On the same Argand diagram, yes. So we need to be careful here, because that there is going to go through 1 and 1. Whereas this one, we might want to rationalize the denominator to look for the center of this. That's u minus a half squared minus a quarter plus v plus a half squared minus a quarter is equal to 0. So u minus a half squared plus v plus a half squared is equal to a half. So we've got a centre plus a half. That's going to be around about here. I might actually just redo my diagram to blow it up a bit because it's going to be difficult to actually get the correct perspective on here. Let's just do that. Okay, that's a bit better, isn't it? So let's just look for the centre of the circle. So the centre is at half minus half. So lo and behold, it's on our line. So perhaps I made a little bit too light of this because question, there's 3 marks available here, not many for the amount of effort we're having today, because we've got a radius of 1 over the square root of 2. Now, if you think about it, this length from here to here, I suspect the length from here to here is equal to a half. Okay, but we've got the centre of the circle going through. We've got the edge of the circle, should I say, going through the point here, because the length from here to here, let's just make this clear, this length here is the square root of 2. So this length here is 1 over the square root of 2, or square root of 2 over 2, which is 1 over the square root of 2. So I think what they're getting at here is we really must make sure that we can show clearly that the circle is going through those points 1, 0 and 0, 1 on our diagram. Okay, so we need to show that clearly. Try and get it right. I do. Ooh, maybe a little bit better effort there, folks. There we go. And also, another thing, it's going through the centre, of course, which we can see from the actual fact that this has got no equations, which is actually an easier way to see it, I suppose. So it's got to go through the centre and through those points. And so that's it. As I say, I think that the examiner has not, although this isn't an unusual technique by any stretch. In fact, the textbook has tended to gravitate towards the Heinemann textbook has tended to gravitate towards this method. But I really, if you look at the mark scheme for this, they've done it slightly differently. And I might do it that way in a later video, so you can take your pick. But I did like it this way because once we'd done all the harder work in part A, part B came out a nice easy 7 marks for that. Okay, no problem. Even with all the waffling, we're 13 minutes into the video, 15 marks. This, a lot of you have got a few issues with this, but it actually, hopefully, once you get used to it, you're not going to be too put off by questions like this in future. Okay, hope you enjoyed it. Bye.